Good afternoon, participant. We have one presentation in the morning, which was how to save our smart cities from flooding. Right, the issue that what I wanted to address in the previous lecture, that was uh, though we are planning smart cities, as the title of this FDP is smart cities. Though we are what you can say developing smart cities, but these smart cities which are on the bank of rivers are getting flooded frequently. So what is flood mitigation measures? So earlier, specifically in central plain of UP, if we will look at the river Ganga or river Gandak or Ghagra or Saryu, right? You find that on either side of the river, approximately 1.5 to 2 kilometers away from the bank, they have constructed the bunds. And these bunds are basically, if you will see the bed width, the bed width is around 8 meter, and top width, if you will see, it will be around 3 to 5 meters, and the height of the bund is approximately equivalent to 3-storied building, that is 10 meters, approximately 10 meters. And they are constructed approximately 1.5 to 2 kilometers away from the bank of the river. So as I said, that in a central plain, the river width is more, depth is less, and hence when there is a huge discharge in the river, that spread over the either side of the bank. And because of that, to protect the villages which are on the other side of the bund, right, these bunds were constructed, and these bunds are constructed somewhere in 40s 50s, right, but they are still protecting number of areas, right. If you will visit the Ganga basin plain, or if you will visit the Ghagra river basin, or if you visit the Buri Gandak and all that. And as I said, that due to recurrent floods, these specific regions, right, the cities which are on the bank of this river, like Patna, you those who remember last year in Patna, the Patna was flooded recurrently. Number of times it was flooded. So every time you see in the news that Patna city get flooded, they blame on stormwater management. They blame on one or other region, and they says that because of the draining system of the Patna city is not good, or the what we can say measures, flood mitigation measures, they are not enough, right, to protect the city from the floods. So that was the first lecture from the topic of smart cities, and from smart cities point of view, how we can protect our smart cities from recurrent floods. In this lecture, the another part of it, that is stormwater management, which is one of the key part of planning of smart cities. That whenever you develop smart cities, one of the major what we can say design, planning and design, that is required of urban stormwater system, right. I remember one incident that has been told by my colleague who is a part of Dholera development plan. And in that Dholera development, one very senior hydraulic engineer, he was present in Dholera development plant, and they were talking about the cost. And when they were talking about the cost of laying of stormwater management system, right, somebody from the expert, he said that let us have this stormwater drainage which is proposed and costing in terms of crores of rupees. Instead of that, let us go for the reduced diameters of the pipes, and revise the stormwater system, and don't go for the stormwater system which is proposed for draining of this Dholera. Sir, that is, you know, that it is a special investigation region, and probably in 2024 or 2025 there is a phase wise development, and in phase wise development after 10 years, probably a city like a Singapore, right, that much initiative, planning, measures, new developments from smart city point of view, that is going on in this Dholera, sir, that is special investigation region. So I was talking about that hydraulic expert, who was very senior person and sitting in the panel of expert. And when this particular suggestion has come, that let us revise the stormwater design so that you can reduce the cost. The hydraulic engineer very politely said, yeah, you can reduce the cost by revising the stormwater drainage system. But remember, once in 100 year, once in even 100 year, a flood comes, and due to that the damages which will happen because of the inadequate stormwater system, which will be 10 times more than the cost which you are saying today. Are you getting me? That what he said? He said that if you are reducing the or if you are designing the stormwater system, redesigning the stormwater system to save cost, but saving of that cost component, right? And damage is caused when there is a heavy rainfall in this specific region. Those damages are more than that of the cost of saving by revising the stormwater system. And everybody agreed to it, and they kept the original design, though the cost was more the same. So stormwater is a very important component of any smart cities. Probably you may be from various part of state of Gujarat, some of you from Vadodara city. If anyone is from Vadodara city, yes, say yes sir. If anyone is from Vadodara, I'm not sitting to participant, what you can say,
Yes,
a
sir.
screen. Yeah, Vadodara is there na. So tell me, what was the situation of the outskirt of a city 5 years back? What was the whenever there is a rainfall, what was happening over the outskirt of the city, like Manjalpur area or areas which are outside the city, right? So Gotri Road or such areas before 5 or 10 years back, from the stormwater point of view. Hello, the one is who is from Vadodara, please reply. Hello, hello, am I audible?
Yes, sir.
So that
Yes,
Vadodara
sir.
guy, what was Vadodara guy? What was the situation of the city before 10 years? Whenever there is a rainfall, what was happening in Vadodara city? The guy said yes, sir. Now he is not
Sir,
replying.
no idea about the last 10 years. I can't give an answer.
Okay, okay. So since how long you are living in city?
Sir, more than 10
Hello.
years, but more than 10 years
Which area you stay? You tell me about your area.
at the
Which area you
Sangam
stay?
area. Sangam area.
Sangam. So what happens after every flood in Sangam Naka or that Sangam Girder? I mean that underground pass. What is happening there?
Almost the
Don't you
roads are
don't
not.
you don't you face waterlogging problem in your area after
Yes,
rainfall?
yes.
Yeah, that's what I am asking, right? So
Hmm.
Sangam area of Vadodara city is one of the worst affected area due to whenever there is a rainfall in that particular area, you find that the streets get flooded in this Sangam area. Okay, not only that, it is one of the most notorious area as far as the stormwater is concerned, that the water enters into the number of societies. I don't know whether they have laid the stormwater system now in that area and that problem has been resolved or not. I have to check specifically for Sangam area. But as a overall Vadodara city, I know that before 10 years back, no good water urban stormwater system was there, but now they have laid number of storm water drain systems in number of areas, and because of that the problem of flooding of street has almost gone zero to certain pockets of Vadodara city, right? So this is an example that why we need to understand the stormwater system, right, and how the stormwater system help. This may be the case of Surat also, right? Surat is considered to be having one of the good urban stormwater system. Otherwise, if you will see, 10 years back there were a number of areas which were flooded even after a few of rainfall, but now that is not the case. But the in case of city of Surat, there is a different problem when there is a huge releases from the Ukai dam, because Surat city is on the downstream side of the Ukai dam. Then what happens, the water into storm drains, right? During high flows in the river, the water starts entering into storm drain, and it due to the storm drains, the number of areas get flooded, and therefore they have installed floodgates on almost most of the storm drain which are discharging into the river Tapi. So this is another problem. Even if you have a good urban stormwater management system, you have to check that whether during high tide like Mumbai, or whether during high flows in the river like Surat, or the water is not entering into the, what you can say, the drains, and that is not flooding the various areas of the city. So I have tried to explain in this lecture basics of stormwater drainage system. At the same time, I'll be explaining you how the modeling can be done, basic principles of it, what are the let's see. But I those who are interested in designing the urban stormwater system or understanding the urban stormwater system, don't live in between, right? I will not ask you question, as I have seen that in the previous lecture when I have started asking the question specifically by name, right? 5 or 6 people left the lecture. So that is actually a loss on a part, that if you are not attending anything, and if you are attending anything, at least you will get some 1%, 2% out of the lecture that may be useful. So with that aim, I will not just point directly with name of anybody, but I'll ask a question in general. You unmute yourself and reply, because I always like to deliver lecture in an interactive way. That is not uh, not that trying to what we can say, ask anyone and put him in an embarrassing situation. That is not the question. It is a continuous teaching learning process. Sometimes you may ask me a question and I may not be able to answer it, right? Why? Because it might have not clicked me, or it's a new for me also. So it's a continuous learning process, and one keeps on learning throughout his or her life. So this basically I have included the various what we can say technical details which is required for design of stormwater drainage system. I will explain you the codes used. I will explain you the manuals which are used for designing of the stormwater system in case of any system. So before we go for this, let us take an example that if the stormwater drainage system is not good, or if you have not paid attention to it. I think Hyderabad is also one of the one of the smart cities, and on 15th October 2020, 10 means October 2020, 50 people died in the torrential rains and flash floods in the city, right? And that is over the Telangana, and the loss of that was around 5,000 crores, right? So what has happened, that we will see here. This is the, yeah, this is the picture which you see on your screen. That is not of any stream or nala. Usually you see such picture on in case of water flowing in river or water flowing in a stream. Here you can see it is a streak, right? Either side there are houses, and you can see the people are also there. Yeah, I can use the pointer now. Yeah, that I got. Let me took that pointer so that you can laser pointer. Yeah, just see here, these are the people who are watching this water which is flowing through the, what you can say, streets. And this water which is flowing through the streets, you can see that how much is the depth. Here is a jeep parked on a street, and almost its tires are underwater. So depth of water is approximately half a meter to 1 meter, right? And as I said, it is not stream, or it is not nala, but it is a street, and through street the water is flowing like this. So this is the what you can say, picture of your FDP. Jagruti ma'am, if you are there, this you can make, or this you can award as a picture of this FDP as why start smart cities, why start smart cities, why smart city planning are required, right? So you can post this picture whenever you are presenting it in front of the authority. Thus see this is again another picture which is of Ganga Pahad Shamshahabad road, in which you can see that luxury car, because of damaged roads, it was parked on a road, and now you can see what is the condition of the car, luxury coach. This is Again, as I said, it is a street, and you will see that instead of vehicles moving on it, it's a boat which is moving off it and rescuing the people. See the picture skew here, that this happens when there is a flood in a city. This has happened because of torrential rain in one of the societies of what we can say the Hyderabad, which is this picture is taken by PTI Indian Express on 15/10/2020. So this gives an example what is the significance of stormwater drainage and how important are stormwater drainages, right? This is again Hyderabad flood. You see this person who is at work and he's having some stick in his hand, and you see that entire road or entire street is flooded with water. Probably this is a man who is trying to open the manhole, right, stormwater manhole, so that he can open it and the water can drain out through the from the city, right? This is again the situation. You don't see the track. This is usually it is said that wherever the railway lines are laid, the top of the railway line is above the high flood level, but in this case you see that the entire railway track is underwater and the train is moving on it. Okay. So this, according to government of Telangana, mandal-wise deviation of rainfall from normal rainfall between 1/6/2020 to 15/2020, right? You see the blue line, that is large excess. So 60% of more water that has been received by Telangana during this period, 1/6/2020 to 15/10/2020, and major part of the Telangana, that has received the large amount of rainfall, which is one of the reason of such type of floods, right? Flash floods. This is the heaviest rainfalls in Hyderabad in 2008, 1908, 153 mm. 2016 it is 215 mm, right? And the hours in just 36 hours, 2020 mm of rainfall on August 2006 took place in 36 hours, while in September 2016 rainfall figures up to September 2020, September 25. So such a huge rainfall is received by Hyderabad the city, which has resulted into the floods in Hyderabad city. So remember, these floods, keep in mind one thing, that in the previous lecture flood which I have shown, that was riverine floods, right? Because of the floods caused in the cities because of flows from the river. This is not riverine flood. Understand the smart city infrastructure requirement from this point of view, that in Hyderabad the flooding is not due to riverine flood, it is due to rainfall. And when it is a high rainfall resulted in Hyderabad city, right, why the number of areas of the city of Hyderabad are under water. Okay, so this is all history about the Hyderabad that I am not reading. But urban drainage system, why we need urban drainage system, after giving this background of what has happened into Hyderabad, one of the, and why we emphasize is the drainage system, good drainage system in smart cities. The reason behind that, drainage system categorized as major or minor system, major, yeah, and we try to classify the urban drainage system. So urban drainage system can be classified into two parts: major drainage system and minor drainage system. If we talk of major drainage system, comprises of open nalas, natural surface drains. Minor system, network of underground pipes and channels. Minor system categorized into two types, separate and combined, right? Separate drainage system consists of two conveyance network, that is sanitary sewer and storm. Sometimes we combine both the sanitary as well as storm drains also. And you will see one of the major problem of storm drain is also in our country, where when we talk about the quality of water, storm, that at many places the sanitary sewers are connected with the storm drains, right? So what is a drainage processes? This is the heart of the lecture, which you will see here, that Mark et al., according to Mark et al. 2004, urban drainage processes can be classified into 1, 2, and 3 components. What are they? Number 1, hydrological model. Number 2, street model, and number 3, pipe flow model. While street model and pipe flow model, that is a hydraulic component, hydraulic model. While only based on the meteorological parameter, what we are developing is our hydrological model. So what hydrological model includes? So hydrological model includes rainfall, catchment area, impervious areas, right, which will result into runoff hydrogram. So this will be used as an input for designing of Number one, either street model or designing of pipe flow model. If you talk of street model, so in case of street and storage routing and water level discharge and inundation. So this hydrograph is used to check what will be the water level, how the water will be moving through the streets, right? And what discharge it can pass, what water level it will have. All this you can study under the street model. While the pipe flow model, if you have an underground streets, underground network of storms, then you should have catch pit which catches the water which takes into the sewer. This may be storm sewer also. Sewer pipe means not necessarily here it is a drainage pipe, but it's a sewer pipe, and that sewer flow routing you have to do, and ultimately you have to discharge it. Water level discharge is to be done. So this specific slide is the, what we can say, the slide which you can use for the purpose of designing of the stormwater urban drainage processes. This is a very important one, right? To understand what are the components of urban drainage. So urban drainage processes, you have you need to have two model, hydrological model and second is hydraulic model. Okay, then the stormwater modeling, as you said, that hydrograph, rainfall and all that, you get hydrograph is the graph of time versus rainfall intensity, how much amount of rain is fallen in what time period, that you can plot it, and that is called as a hydrograph. This hydrograph result into overland flow, that is what we call as runoff. So what are the components of rainfall runoff models? So that overland flow, at which time what discharge and what may be the peak discharge, that we wanted to find it out, that, and it will be used T versus Q. What is the requirement of that is rainfall runoff modeling? You need a hydrograph. What is hydrograph? That is a time versus that of the discharge curve, right? That is time versus discharge curve, that will give you the storm hydrograph, which is used for the design of stormwater what you can say, the storm network. Okay, why? The amount of rain which will enter into the pipes, right? Storm drain system may be open or closed, that depend upon this factor. What is that? C is your coefficient of runoff, right? That how much water will enter into the stormwater network and how much will be lost, right, over the ground. So that graph, these two things, two data, number one, this is data number one, that is hydrograph, and number, that is what you can say, that is the coefficient, and with the time, what is the coefficient and time. These are the two inputs for rainfall runoff modeling. So if you are doing the rainfall runoff modeling, these are the two inputs which are required for. And again, this is the overland flow routing. Now flow routing through drainage system, right? This drainage system which you wanted to design, right? So how much water will enter, how much will leave, what will be the ponding on the surface, all this you wanted to calculate. For that you require flow routing, right? Because your stormwater drain is not only of few meters, it may be of few kilometers, right? And it may take time, as well as there are intermediate pipes which are connecting, what you can say, the main line. And that may happen, because of that it may happen that some of the areas which will not be able to drain of water, connecting network may not be able to drain of water water for the same diameter of pipe. What I am trying to explain is, suppose this line we have drawn, it is my main line, right? And you have a connecting stormwater lines from various societies like this. Okay, now what happens in case, right, this is the connecting line and this is my, what you can say, the flow direction. What happens, because of heavy rainfall over this catchment area, right from this point onwards, right, the storm water flows full, right? Then what will happen to these flow lines and these flow lines, right? Water will not enter from these tributaries when the main line is flowing full, right? And that time this particular water that will not enter, because already the design pipe is flowing full, hence this will drain the water, and hence the areas which are over here or over here or here over here, that will get flooded. Okay, and this flooding will remain till the main line become empty. right? Or the when main line takes water from the what you can say sub drains. Okay, so this is main drain and these are the sub drains. So water will not be flowing into the main drain if the main drain is running full. And recently I carried out one consultancy work for Jahangirabad Gujarat Housing Board Society, and in Jahangirabad Gujarat Housing Board Society, same was the problem that their drain, there were three drains which are draining into 11 towers, and it was spread over half an acre area. And out of three storm drains, the water was drained into the main drain. But this Surat Municipal Corporation main drains, when it was flowing full, not only these three drains which are draining water from Gujarat Housing Board campus at Jahangirabad, the water from main drain start flowing backward into campus, right? And the campus remained flooded for a number of days, right? So then I proposed to provide a floodgate over here, and one more drain was there in three drains, right? That is the solution which has been given by me to avoid flooding of the campus when there is a main drain is full, number one. And number two, that for these three drain, when you close this floodgate, it will happen the water which is required to be drained out of the campus may get impounding into the campus. So for that I have given a solution that you construct a sump here and put a pump over here, so that this pump will start pumping the water from the campus into the road, outside the road. This is a SMC road outside, so you can pump that water so that the what you can say impounding, by that you cannot stop what you can say impounding of water, but definitely you can reduce the depth of water of impounding inside the campus. So this solution was recently given to me to Gujarat Housing Board for their storm drainage system, right? So the component of stormwater modeling are rainfall. For that, hydrograph is required to be prepared, overland flow routing. For that need hydrograph, inflow hydrograph, and the coefficient of runoff that is required depending upon how it will be vary with the time, because you know that initially, suppose there is a monsoon rainfall in the month of June, right? When the rainfall has just started, the soil may not have that much moisture. But if the rainfall progresses, right, June, July, August, and there is a good rainfall year, the soil may have a sufficient amount of moisture, and the coefficient of runoff may increase, right? So because of that, what will happen? The peak, that is runoff, generated runoff may increase. So this also you are to required to give as an input, whatever software you use. This figure 8 is the basic figure which requires the data, which write data in this form. That is rainfall, you need hydrograph. For overland flow, you need hydrograph and a coefficient of runoff and routing. That how much water can be transported, right? How much water can be transported from one location to another location in what time period, right? So it will not happen that inflow hydrograph will exactly match with that of the outflow hydrograph. There may be some lag, and that lag is nothing. That lag results into the picture like this, right? If you have seen that this picture like this, so this is due to lag. Suppose on this road there is a stormwater drainage system, but even having this stormwater drainage system, you for example, I am saying I don't know whether the stormwater drain, because the man is on work, that means there may be a stormwater drainage system here. But even though the stormwater drainage system is there, it has resulted into the ponding of water. Looking to their feet, I think so it is around 10 centimeter, 10 to 12 centimeter water is impounded on this freight. Okay, and when this man opens the manhole, the water will start draining out of it. But even though the manhole is there, why this ponding has happened? Because the rainfall and the runoff volume is more than that of the capacity of the drain. So that is the figure which shows this third one, which I am explaining, you know, this third graph, that is flow routing, right? And till the capacity of your stormwater drain, what will happen? If the amount of volume of runoff generated is more than the capacity of a storm drain system, it will result into the impounding of water. If it is less, then what will happen? It will be drained out of it, right? And the quality also, because in developing countries, of course, now the awareness has started that the storm water should not get mixed with the sewer water, and therefore you can take up the samples at number of places. Those students who are attending this particular presentation and wants to do some sort of innovative study, they can ask their student, or the student also can take up the dissertation topic or research topic, wherein they can collect the sample of water from number of storm drains and study what is the quality of stormwater drain of urban cities, right? And that is called as a quality module. So it is written quality routing through drainage system. So here also you can find it out. Suppose you take a sample over here, you take a sample over here, you can take sample over here, right? You can take sample over here, you can take sample over here, you can take sample over here also in the beginning also. So you can have the quality check what happens with the length of the storm drainage system. Suppose this is a 0 meter channel, and this is a 10 meter chainage, right? Then 10 kilometer chainage. So throughout the 10 kilometer, how the quality of your storm water varies, right? That you can try to find it out for various drains of your study area, right? Or any of the smart city. So this is also a kind of topic of research, or a topic of MTech dissertation, where you can analyze the quality of water into what you can say the stormwater system. So this all I will not read, because it is already what I have explained you, right? That is urban design requirements. What is that? So you should know the advocate functioning of drainage system based on sound hydrology and hydrologic their design principle. Design of an urban drainage system requires knowledge of the catchment area, topography knowledge of the catchment, and urbanization details, rainfall intensity, hydrology and hydraulics of the area. Watershed catchment as basis of drainage, urban drainage design. So when we say that watershed and catchment, right? I'll go back to this figure again, right? Wherein some of you have got, or definitely have got idea, but even then I say that, see, this much of water is flowing to this street. That means what? It's, if you look at this particular area on a plan, and you will see that from the figure also you can get idea that this is not on a flat terrain, right? If you will see farthest, the level is down, then it is one step ahead, one step above. Here the level is further, or I think this is a surge wave, but here you can see that the level is up, level is higher. Means probably this is settled on a hilly area, wherein it may be a catchment area for a water flow, and this specific society is developed in a waterway, right? Which means the catchment area, the water is supposed to pass through that area, and in that area the people have built the society. So that's why it is written that you should know the topography, you should know the slope of the area, right? From where, what you can say, or how the water will flow through the system. So that is watershed or catchment area as a basis of urban drainage. Very simple. This is not all things are very complicated. You can use a DEM of a specific resolution. If you use a finer resolution DEM, you can get the slope of the areas very easily. Someone of you may ask me, sir, from where we will get the map of such a fine resolution from for various city areas, right? Simply you visit ISRO website, right? And if you visit the ISRO website, on ISRO website you can find, right, the finer resolution map, which may be useful for finding out the slope area, finding out the amount of runoff, and specifically direction of a flow, right? That in which direction the water will flow. All this you can find it out from the image, which is freely available on the ISRO website, right? Ahmedabad ISRO website you check, or you check it at the Dehradun website, and even you can write to them. They may provide you the image up to certain resolution free of cost. If you go for a finer resolution, you may require to pay for it. But again, you are using it for which purpose? That academic purpose. The cost of the what we can say that cost of image is very less. Okay, so you need rainfall data. Of course, I have explained you that rainfall data is required, and from rainfall data you are required to prepare IFD curves, that is called intensity duration frequency analysis curve, and these IFD curves are prepared for minimum resolution of 15 minutes. I think I have IFD curve. This is a rainfall data, so rainfall figures you can note down this side. Somebody will say that, sir, हमको तो rainfall data ही नहीं मिलता. Yeah, nowadays it is not that difficult, and it was 5 years or 10 years back. Those faculties who are attending this particular presentation may note this is a website from you which you can get the data, or you can write to that is the data center Gandhinagar, from where also you will get the data, or you can check IMD website, or you can check IITM Pune website, and the data for your region may be available. So you can see here such type of rainfall data are available, which can be used for a specific date. It is there nowadays. Even they are recording hourly data if they have a what you can say that weather stations, right? Because weather stations are also installed in the cities, and these weather stations are recording rainfall data of every hour. Hourly rainfall data are available. Probably you are in Vallabhidhyanagar, you can check with Anand Municipal Corporation and or Anand Nagar Palika, whatever it may be. Probably they also have installed the weather data, and it may be active and recording the rainfall, hourly rainfall for last 4-5 years. And during this, if there is any extreme rainfall event or high rain event, directly you will get the rainfall data, and that you can use for the analysis of stormwater drainage system of Vallabhidhyanagar, or you can analysis of your area, or even you can do it for your BBM engineering college itself, right? This is the website which I am showing, indiavaris.gov.in/varis, where from where you can download the rainfall data. And even the below the important links are also given. This will be a very useful site for you. This is again, select the area of focus, how to download the what you can say data from India Varis. I have tried to incorporate that slide also, and select the area for which the data required to be downloaded, like Surat, and the period whatever it may be you want, you can download the data, right? Select the dates and times, step details, and download this chart in PDF format. And if you can, you will click CSV format, the data will be available in a Excel formats, right? So friends, if you are attending this particular lecture and you are really interested in doing stormwater drainage design network, this is the rainfall data, and this side, this particular 4-5 slides, this is the first slide, this is the second slide, this third slide, this fourth slide, this the fifth slide. This gives you idea how you will get rainfall data of your area in CSV format from which site? With India Varis site. Okay, now estimation of missing data. Naturally, there are data which is not available in the what you can say the data which you have downloaded in the form file, and there are a certain missing data. There are so many techniques of finding missing data. Those who are interested in or carrying out this study on stormwater drainage system or doing research on this may note Ramesh Tigavarapu. Ramesh Tigavarapu, Dr. T, popularly known as Dr. T, from Florida University, Orlando, USA. Dr. T, Florida University, Orlando, USA. Right, he has given number of methods. Just visit his web page, and there are lots of research material which is only one click away. You are not required to pay a single paisa for it, right? So you can download those methods, you can read it. I have explained you here one method, which is a normal ratio method. And in normal ratio method, suppose px value is unknown, and you have p1 value, p2 value, pm values for a number of data points, right? Then how you can find it out, the missing value? That is first method, which is called as normal ratio method. And using that normal ratio method, you can find it out the missing value. The second method is modified normal ratio method. This is the equation given here, and this also can be used to find it out the missing data of rainfall for this, right? Then the most popularly used method for finding out missing data is IDM. The full form of it is inverse distance method. This inverse distance method can be used for finding out the data, missing data, and how it is to be done. So rainfall measured at the surrounding index stations, that is to be collected. Distance to each station is to be find it out. Suppose you have one station which is missing, but there may be number of station around where the data are available. So you find out that distances, and then you can use this specific formula to find it out. This is the second step which you can find it out, and from that you can find it out the missing values. So I'm going step by step how you have to go for the design of stormwater drainage system, and in that the first important is the rainfall data, where you will get the rainfall data for India, that I have explained you. Then I have discussed second point, that is missing data. So how to find it out missing data? So three methods I have explained you for missing data: IDM method or I inverse distance method, that is used for popularly used for finding out the missing data. Sir, this is very preliminary. I want to use some advanced method of finding out the missing data. Then I have given you the reference of Dr. T. Tiggavaru Ramesh, professor of Orlando University, Florida. Okay, so you visit his webpage and you can find it out, number of methods, and even his book is there, in which the precipitation analysis and various methods of estimating the precipitation has been given. So we finished the rainfall analysis. So now what is required? We required to develop hydrogram, the first step, right, of rainfall runoff modeling, that is stormwater modeling, to develop a hydrogram. So hydrogram can be developed using for various time interval. Hydrograph that I have shown you in the basic chart of it. What is that? T versus rainfall. Yeah, this one. This is a T versus intensity, time versus intensity. Here you can see that it is a time versus intensity graph, that rainfall. Once you got the rainfall data, so what is your first requirement? You have to prepare a hydrograph where time versus intensity you have to find it out. So this particular step, in this particular step, after missing data, you have to prepare the rainfall hydrograph, and that hydrograph you can prepare based on what you can say different time interval, and it is also given as a guideline for urban drainage problems. Less duration are used, and for flood flow computation, higher intervals, about 6 hours, can be used. So the hydrograph, what resolution or what scale of hydrograph are required for stormwater modeling and flood modeling? So if it is a stormwater modeling for urban drainage problems, less duration, 15 minutes, 30 minutes, 1 hour, 2 hours rainfall duration hydrographs are required for urban drainage problems, for designing of stormwater drainage system. While if you go for flood computations, you need higher resolution, that is a 6-hour duration hydrographs. So what is hydrograph? So that is shown over here, that first 10 minutes the rainfall has fallen with 0.8 inch per hour intensity, then 10 to 20, 20 to 30. The duration of rainfall was 1 hour. So during 1 hour rainfall with this intensity, the rainfall has fallen. So this is a picture of graph versus rainfall intensity, that hydrograph you are required to prepare. Once you prepare the hydrograph, as I said, that you have to design your stormwater system for a particular recurrent interval and return period. So what is recurrence interval and return period? That we will understand. This is the next step of designing of stormwater drainage system, a return period. So what is return period, or also known as recurrent interval or repeat interval, is an average time or estimated average time between events such as earthquake, floods, landslide, or a river discharge flow to occur again. So it is statistically a measurement typically based on historic data over an extended period, and is used usually for risk analysis n+1 upon m. Recurrent interval is given as n+1 upon m. So when you are designing a drainage system, right? So as you have seen in case of flood in Hyderabad, we have seen the rainfall. So that rainfall was maybe a rainfall of once in 100 years. Means the rain of that magnitude falls after 100 years. The probability of falling of that rainfall is after 100 years, right? So how to find it out, that what will be the intensity of rainfall you consider for what period? For example, you want to consider a rainfall of 2 years period, so it may be having a very less amount of magnitude of rainfall. If you consider 1 year, still it is lesser. But if you consider of 5 years, it is more than that of 2 year rainfall depth. If you consider for 50 year, the rainfall depth may be more for the same area. If you consider for 100 year, the rainfall depth may be still higher than that of what you can say 50 years. So that is recurrent interval and return period, that after how many recurrent interval means how often that event can be repeated, right? For example, if I say that 4 inch of rain is fallen in say 24 hours. So after 4 inch of rain is fallen after 24 in 24 hours for Surat. Okay, so recurrence interval means after how many areas again it will fall, right? 4 inch of rainfall in 24 hours. How much years, how frequent? If I have a record of say 50 years, so how frequent it has happened, that is recurrence interval. And return period is after how many years a specific amount of rainfall will fall again, that is called return period. So recurrent interval n+1 upon m, this is a popular formula which is used to find it out, the recurrence interval and the return period of the floods. Then intensity duration, because what happens that the amount of rain fallen and its duration is different for different cities or for different areas, and therefore what we do, we plot for IF curves, right? And from this IDF curves we get idea that how much of rainfall is required to be considered for the design of it. So I know the Palvi has developed, one of my student who is attending this presentation, she has developed IDF curve using, I think, Palvi, 150 years of data. Palvi, are you there? Or Surat?
Yes, I'm there. Yes, it's 150 years data.
150 years. So we together, Palvi and myself, have developed for the same, the case of Jahangirabad Gujarat Housing Board consultancy work. I asked Palvi to develop IDF curve using the data of 150 years of Surat city, right? And from that I have considered the intensity of rainfall that will help me for finding out what you can say the amount of runoff generated in that particular area, which I will use for the designing of the stormwater or for the analysis of the stormwater drainage system, which is already there, that up to what amount of rainfall for which intensity the existing storm drain is capable of disposing of water from the campus, and if it exceed beyond that, what will happen in the campus, that what analysis we have carried out using 150 years of data of rainfall, right? So these are the some of the points why we need to develop our IDF curve, and how this IDF curve can be used for this one, right? So for development of IDF curve, the steps are given. First, you have to prepare annual maximum data series. From that, from the available rainfall data, rainfall series for different duration, 1 hour, 2 hour, 6 hour, 12 hour, 24 hour are developed. For each selected duration, the annual maximum rainfall depths are calculated. Then we have fitted it to probability distribution. A suitable probability distribution is fitted to the selected data. The most widely used the probability distribution for Indian rainfall is log normal distribution. Gumbels is used for extreme value distribution. These are the name. Log Pearson type 3. Log Pearson type 3 distribution is the most popularly used distribution for Indian rainfall analysis. There are other many probability distribution curves are there, and depending upon the region, like USA, UK, Nepal, Sri Lanka, Dhaka, Bangladesh, right? You can use the different probability distribution for fitting of IDF curve, right? So India, we are usually using the log Pearson type 3, if I am not wrong, right? So determining the, then third step is determining the rainfall depth using frequency factor, and using the cumulative distribution frequency of the distribution, we can be finding out the cumulative distribution frequency curves. That is the stuff of fourth step. The what are the frequency factors you can consider, some of the equations which are shown in here. Then using the cumulative cumulative distribution frequency curve, these equations are given, and this type of return curves are prepared, right? IDF curves are prepared. So what are basically IDF curves? They, on x-axis you have a return period, and y-axis a maximum rainfall intensity. What does this mean? For example, if I take 1 hour, okay, and if I draw a line from here for 100-year return period for 1 hour, for this IDF curve, what intensity I should consider? So this will be my intensity approximately, right? So I may consider 30 centimeter per hour, right? So for 100-hour return period, for 100-year return period, means for 1 hour duration, once in 100 year, there is a probability of 30 centimeter of rainfall in 1 hour. 30 centimeter of rainfall in 1 hour. That is called as IDF curve. Again, you may have an IDF curve of this nature also, that is duration and maximum rainfall intensity, right? So for various return periods. So here the return period curve is there. In this case, the return period is on axis, right? Suppose for storm drain design, we consider 100-year period, because this return period is different for different designing, right? So for storm drain design, we can consider 100-year return period. So for 100-year return period, if I wanted to consider 1 hour rainfall for duration of 1 hour, right, this gives me approximately 32 centimeter of rainfall per hour, right? So this is again, this is also IDF curve, that is duration and the intensity, rainfall intensity centimeter per hour. This is again if you are using a software input, right, for designing of your storm drain system, that you have to develop considering what you can say the data of rainfall as much maximum as possible. So we have used 150 years of data for finding out what will be the duration, intensity of rainfall for city of Surat. Why? Because we wanted to examine what was the work assigned to me, that I have to check whether sufficiency of existing stormwater drainage system of Gujarat Housing Board campus at Jahangirabad. So for that we have developed and we have considered this rainfall intensity for checking the existing stormwater drainage system of the Jahangirabad Gujarat Housing Board campus, Surat. But this IDF curve is the next step which is required to be developed and can be used for the design of what you can say the IDF curves. So this is again a sequence example for developing of IDF curve, in which the data is taken and then how 15 meter, 15, 30 minute, 50 minute, 45 minutes, 60 minutes, 75 minutes, and 90 minutes, how the data be used and analyzed, and the rainfall amount can be calculated from the data which you have. That is the step 1. Yeah, and somebody will ask, sir, आप तो ये सब बोल के चले जाओगे, then from here I can get all this. So please note down this CPHEEO manual, that is Center for Public Health Engineering EO organization. That double E is for engineering and something, and organization manual, CPH. This is popularly known as CPHEO manual. So please refer CPHEO manual, and in CPHEO manual they have given this example of developing of the IDF curve by which method? Gumbel's method, right? The CPHEO manual, this particular IDF curve example which I am showing here, that is given, then that is to be used for what you can say fitting of the probability distribution. Then second step is similarly maximum rainfall depths for each year. Minute duration is obtained for entire sample size, that is for 25 years, and thus annual maximum series has been prepared as given in table 2. So this is the annual maximum series for 15 minute, 30 minute, 45 minute data you have to collect, and you have to pick up the value, maximum value out of a entire sample size. That in 1979, what was the maximum amount of rain fallen in 15 minutes? So it was 21.5 mm. Right? What was the maximum amount of fallen in 45 minutes? So that is 32.5 minutes. Like that, you have to analyze the entire sample size 1979 to 2003. Right? So maximum annual series. So this is, therefore it is called as maximum annual series rainfall depth. This is the annual. You can do it for daily also, you can do it for hourly also. Okay, you can take 10 minutes every year, 10, 20, 30, 40, up to 60 minutes. So hourly rainfall, if you have data of hourly rainfall, you can prepare such maximum daily series rainfall depth. This is what maximum annual series rainfall depth. Maximum annual series rainfall depth using that of the Gumbel's method, and reference you will get for this method again, CPHEEO manual. Right? Then next is fitting of Gumbel's distribution. So these are the equations which are used for Gumbel's distribution method, and from that it has been computed that intensity in mm per hour for 15 minutes for the data is 112, 30 minutes is 81, 45 minutes 70, 60 minutes is 60, and like that. Right? So computational using that of Gumbel's distribution method, you can find it out the intensity in mm per hour, and this way you can plot a graph duration versus intensity, for that specific rainfall data. So here the recurrent interval, here what will come? Return period will come, and that return period is how much return year period? 5-year return period. So this kind of curve you can prepare, and this may be used in further analysis. Then construction of IDF curve using second method. What is that? Log Pearson type 3. The similar process is carried out. These are the equation used for log Pearson type 3 distribution, and from that you can find it out that various values of the rainfall intensity for different duration. And I think third method is also used, and this is the curve for 5-year return period. Right? And that way, out of these two you can choose any one. Right? We have log Pearson type 3 method, and we have what you can say Gumbel's distribution method. Right? For let's say for 60-minute duration, it gives 60 mm of rainfall, Gumbel's duration method. And if you will check by log Pearson method, it is almost giving the same, 60, slightly less, it gives 58 mm of rainfall. So this way you can fit the probability distribution to your data, and you can develop a this is a 5-year return period curve from your data. Right? So that is the next step. Now once you have computed the intensity, now the runoff is required to be computed, and that runoff is to be computed using other various methods of computing runoff. And for that computation of runoff, we have various formulas to compute runoff. Right? The factors which affect the runoff and all that I am not considering. Of course, briefly, pattern of precipitation, intensity, rainfall distribution, deficiency of soil moisture, evapotranspiration, etc. Size and number of ditches, depression, river streams, ponds, vegetation, topographical conditions. These are the factors which are used for computation of runoff. The most popular method which is used for computation of runoff is rational method. And in case of rational method, Q is equal to 10 CIF formula is used, where Q is runoff in meter cube per hour, C is the coefficient of runoff, I is intensity of rainfall in mm per hour, and A is drainage area in hectares. Whenever you use rational formula, please be sure about the units. Right? Because different books give different for rational formula for finding out the runoff, but you must be sure that in which unit they have worked out. As I have taken Q is equal to 10 CIA, you may get CIA upon 3.6. The another formula, another form of the rational method, but in that case the units may be different. So in this you get the discharge in meter cube per hour, right? So a rational method can be used for this. Yeah, and then the importance of time of concentration, because the runoff is generated, but the runoff from farthest point it has to reach to the channel inlet or that of the stormwater inlet. So it takes travel time. So that travel time is from the farthest point to the inlet point of the channel, and I mean that of the storm drain, and the flow which is taking place inside the channel, that is time of overland flow or time of flow, TF. So T, time of entry, and time of flow, TF, in the drain up to that particular point, right? So probable future condition of the that is also required to be find it out, and this can be used. This is about the coefficient of runoff which you have to consider based on the imperviousness, open area. You get a ready-made table in CPHEO manual also, that how much area you have to consider. And suppose if you have a different areas, means some vegetation is there, some paved surface is there, some what we can say the pond areas are there, then what you can do, you can find it out the computed C weighted C coefficient, which is also taken from the CPHEO manual method, wherein you can see here the total area is again built up area, open area, 60% and 40%, and based on that how to compute the coefficient of coefficient of runoff, that has been computed in the last column, right, which can be used for the computation of. Then as I said, time of concentration, which is the summation of time of entry plus time of flow in the channel. So time of flow in the channel is the length of the proposed drain divided by flow velocity in the proposed drain, that will give you TF, and T, that you have to find it out that how much time it will take from the farthest point to that of the drainage. So this figure shows you how the time of concentration be computed. So you will see here, this is a drain, thick pink line is a drain, and this is a draining nala, right? So in which from drain it is discharged into the draining nala. Okay, and there are two drains. You will see here the drain 1 which is in the upward, drain 2 is in the below, right? So you have to divide that area. So where you are dividing the area, that is called median line, right? So area in this part, right, it will drain to this drain 1, and area of this part that will drain into drain 2. Okay, so from the farthest point of the catchment, the time required to flow water from farthest point to the drain, that is T1. Okay, and from here to that of the nala up to this, the time required for water to flow from this point to this point in the nala, that is my time 2, that is called TF, right? So this is T and this is TF. So T1 plus T2, so that will give me time of concentration T1 plus T2. Because why this is important? This will give you idea that how much water can be safely discharged from this particular area, right, through this drain, right? And if your amount of runoff computed or amount of runoff generated is more than the time required for emptying out of the tank, as I said, it comes full, right? So here the inflow is so high that T1 plus T2, right, that is time of concentration, is such that it matches with the inflow over here, the total capacity of the flow. Then what will happen? The entire drain will be full right from here. There won't be any water which will be entering in between, right? So that is the significance of what you can say time of computations, and this explain you nicely what is the signification of time of concentration. So time, how to compute that time of inlet, that is Kripich formula is been given. L is the length of overland flow and H is the difference of elevation. Means if I will look at this figure, then this is my L, and if I have a reduced level at this point and reduced level at this point, difference of these two is head H, which will be driving water into the flow. So that is T, time of concentration is given over here. Permissible velocity, you should have not excessive velocity. This is Manning's formula, everyone knows it very well, and from that you can compute it. The permissible velocity as per CPHEO manual 2012 number 3 and 3 to 26, you will find meter per second, but practically it was restricted to 3 meter per second. So in drain, the maximum permissible velocity is 3 meter per second and minimum is 0.6 meter per second, right? And minimum velocity at peak flow is 0.8 meter per second. So these are the permission velocity which you have to keep in mind while designing the stormwater network as per CPHEO manual 2010. Then the size of the drain. So the economic size of the drain, the width is as per the local width available for the construction of the drains. The depth should be estimated based on Manning's formula because slope is there. And as far as if you are constructing a rectangular drain, open drain, then B is 2 times that of the depth. The width of the drain is 2 times that of the depth of the channel. And if you are taking a circular section, then you have to follow IRC 250, IRC 50, and as per IRC 50, the minimum width of drain should not be less than 250 mm, right? And the diameter, and in case of pipe, the minimum diameter should not be less than 450 mm. So this is a crown level and this is the invert level, and this is the thickness of the pipe which are used for the designing of, right? So at intervals you have to provide the manholes, the number of spacing of manholes and number of manholes that are also required to be followed as per CPHEO manual. This is a grate which is used as an inlet member, inlet catch member. So water is flowing to it and then it will be taken into the stormwater drain. This is a curb opening. Sometimes the inlet is provided in the curb. This is the footpath curb, and in that curb this opening is provided and the water flows inside it through curb opening, right? Then inlet chambers, combined inlet, this is two things, that is curb opening also and inlet chamber also, two are provided in one place. Then inlet chambers of like these are also slotted drain inlet, through which the water will enter. From this it will flow, from this it will flow. In the center the openings are there through which the water will enter into the storm drain which is provided below it, right? Then this is a picture of inlet chamber again I am showing, which will be used for catching the water from this. This is the inlet chamber combined, this inlet and the curb also. Curb is also there, and here you can see that this is a picture of a manhole and only this is a curb inlet, no inlet chamber. This is along with curb and inlet. Here it is only that is below the curb, the inlet chamber is provided. Junctions, we have to couple the sub drain with the main drain. Always you have to couple it obliquely, never combine it 90 degree, right? The 45 degree or 87 degree. 90 degree is not allowed. If you will connect it 90 degree, the water from the main drain will not flow into the sub drain. So this is again a angle which is required to be provided for junctions, right? What are the wrong practices? So some of the pictures I have taken over here, you just see that this is the storm drain, right, which is provided here. This is the road, this is the road, this is the curb here provided, and there is no inlet to this from the roads, right? There should be some inlet provided from either side of the road so that the water can drain into the channel, right? So that is not there. Here you see that wrong practices, storm drain unable to handle volume of runoff. Some of you have seen during the monsoon season that instead of water draining into the drain and draining into the storm water, the water is flowing back from the storm water. When this happens, when the storm drain is full, right, and it is leading to lower elevation from higher elevation and it is full, then what will happen? It will, if the manhole, right, that which is provided on it is of not of enough capacity to withstand the pressure of the flowing water, what will happen? It will move the manhole and water will start flowing back out of it. And this was exactly happening in case of that Jahangirabad Gujarat housing campus, where because of backwater flow the water was entering into the campus, right? This is again a wrong practice. You just see that the inlet is higher than the surrounding ground, right? So don't be such type of an engineer whenever you are because you also be practicing in the field, right? And you see that the because of one or other reason the inlet remains higher than that of the ground. Specifically this happens in case of roads, when they raise the road or when they lower the road, the chamber remains high and the road goes down. when there is a cutting in road because during the construction of a road. This is again wrong practice. You will see that how much water is ponded around the inlet chamber, right? Yeah, this surrounding is this inlet chamber is higher than that of the slope of. This should at least be 1 inch lower than the surrounding areas. Then the water drain efficiently into this chamber, right? So what are the software used for the design of stormwater drain? So it is hack HMS, which is the free software. SWMM, most popularly used software for development of for design of stormwater management, that is a SWMM software. This can be used for freely downloadable MyCarbon, which is very costly software, but it is having GIS interface developed by DHI India. I mean DHI company, and it is a GIS interface. If you know the GIS, if you have a map area of a city, you can combine it with the design software, and you can have computations and design of network based on the MyCarbon using MyCarbon software. But this is a costly software. Why am Water Gems? It is also not a free software, but popularly used. Again, a costly software. Bentley stormwater modeling and analysis software. This is also one of the costly software for stormwater modeling. Then Hydrology Studio. This is also one of the software which is used for designing of a software. I remember, I want to share one story with you, a small story with you, that when Bentley introduced the stormwater modeling software, right, and the representative of it probably have checked a website, and from my biodata, and the representative of state of Gujarat have called me, and he told me that, sir, we have a stormwater modeling software, and we want to give you demo, etc., and want to show you the capability of our software. So that I allowed him, and he visited me, and this I am talking somewhere about 15-20 years back, 15 years back. He visited my office, and he has demonstrated the Bentley software to me, and I found it quite interesting. Then I asked him what is the cost. The cost was in terms of lakhs of rupees, maybe around 25 or 30 lakhs of rupees or so. And the Bentley stormware modeling software which he has showed me have so much of components, right, parameters which the software have. Probably in India, many of them we were not measuring. Right? If you go to, because some of you may be working in developed countries, right, in a later part of your life, or you may be working designer for some of the world-renowned companies, then they have so much of minor data like soil moisture, if I'll say, infiltration, I will say, right, the root depth, I will say. These are the data which I don't think that we will nowadays we can find, but earlier, 15 years back, it was difficult to get such data for Indian context, and the price of software was very, very high. Then he asked me that, sir, what is the solution? That you develop or you modify your software such that it can have Indian inputs, and at the same time the cost be affordable by what you can say the people who purchase this software. He asked me some references. I have given him references of consultant who are working in Surat, and he presented the same work which he has presented in front of me to them, and they also said same thing, sir, your software is good, but your cost is very high. Then probably that feedback is gone back to Bentley, and I knew that later on they have modified the storm software, and they have reduced the cost of the software nearly to the half. And now this Bentley software is also popularly used in India for stormwater design purpose. So here it's a very good the paper you note down, those who wanted to work in this area, Harris ETL 2016, and he has compared the capabilities of various urban models which are used for designing of stormwater or drainage system or stormwater network. For example, drains. So planning, it includes operation, it includes design. It is not available in a public domain, but you have to buy it. That is accessibility public domain. When it is public domain, it is a free software, and when it is a commercial, you have to pay for it, right? Similarly, you check SWM, then you will see that's a planning, right, a designing component, and it is freely downloadable. So that what I said, it is a free software which you can download. SWMM, this is also, and this is hack HMS also, but you will see that it's operational, and it's hack HMS is a free now, it's not commercial one, but because 2016, but I have to check a module again, because if it is written commercial, probably the stormwater component may be main you need to buy, right? It won't. Otherwise, hack HMS is a free software, free downloadable. But as far as stormwater is that component may be a commercial one. So mic software, you will see you can do planning, you can do operation, you can do designing, but it is not available freely. You have to buy it. So this Harris ETL you can refer. It is one of the good paper, and very good as far as the stormwater designing is concerned. Then again, this is another software which is a model characteristic. So routing and time modeling. So what kind of modeling you can do for hydrologic, hydraulic, simple storage, continuous, and event based. So drain, as it is a commercial, but all options are available. You can do hydrologic modeling, you can do hydraulic modeling, you can do continuous event modeling, you can do only event based modeling. So similarly, if you would say SWMM, right, so you will find hydrologic, then you will find hydraulic. Here it is written 1 and 2, that means conditionally it is available for SWMM, and it is not continuous, but it is used on a event based. So again, this data is from Harris ETL paper 2016, which gives you comparison of various stormwater modules, right? Characteristic of various stormwater modules which can be used for software which are used for, right? Though I have discussed the stormwater drainage system and stormwater drainage modeling and explain the components, till there are challenges. You will see this is a picture. Those who are familiar with the Bombay, this is Dadar, which is a very famous area of Dadar near the Dadar station. And again, the various population location Kailas Lassi 23/9/2020. Do you think that the drain waters, stormwater drains are not here? Yes, stormwater drains do present here, but because of excessive amount of rainfall, which may be exceeding the 100-year return period, because when you are designing your stormwater drain, you are designing it for a specific intensity. Say you have taken 60 mm rainfall in 1 hour, and when the rainfall is 120 mm in 1 hour, what will happen? This side, these are the pictures which are showing you that when there is a high rainfall in 1 hour, it will result into ponding of water like this, right? This is there. Then this is again Hind Mata, Dadar Parel 23. Of course, as I said, that stormwater drainage system is existing here, but the amount of rainfall is so high that it is not disposing of the volume of water generated through the existing storm drainage system. This is a central and western railway track flooded between Dadar and Parel. This is a picture of it. Right, though this area have a good stormwater drainage system, because of amount of rainfall, right? So increasing intensity is induced by climate change, urban heat islands, and other factors will possibly result in varying return periods for a given intensity of rainfall. Some of you may question me, तो sir ऐसा क्यों नहीं करते कि instead of 60 mm per hour rainfall, you design for 120 mm per hour rainfall? Yes, we can do that, but the diameter of the pipes will be double, and the cost will also be double, right? So by increasing the diameter of course you can dispose of the water, but at the same time your cost will be increased and it may not be economical, right? From economically justifiable. Therefore we have to stop somewhere, right? Considering that this system will drain off water up to this mm only. If it is more than that, definitely it is going to impound, right? So higher catchment areas, peak flow computation, approximation of runoff coefficients, right? Recommendation for effective stormwater management, risk mapping of the areas of the city should be done to assess the vulnerability related to urban floods using GIS technologies. Now, what happens that whenever the consultant work or whenever as a student you start designing of stormwater drain, right? Yeah, what you do, you start reverse. First, you find out the software, and then you start finding out the data. Then you put the data in software, and when you get the results incompatible, right? You start looking at the software, right? Why? Because the region or the area for which you are applying that software is not capable of doing network design under such circumstances. So that's why it is written here that you have to check the city vulnerability of a city, yeah, right, slopes, etc. For, and even you can use the GIS technologies for that, and then you choose the software, or then you choose the methodology for designing of what you can say the storm drainage system. Again, as I said, the high intensity rainfall 60 mm per hour and 120 mm per hour, you cannot design it. So there is a limitation of it, right? Regular monitoring prohibited areas from encroachment. Again, suppose if you have designed a good storm network distribution system, but you find that the from where the water is to flow freely from that area that has been encroached, or no proper ways have been maintained to drain of water into the natural stream, resulted into flooding of the areas. Conserve and protects areas for groundwater recharge, whatever may be the natural resources, streams are there, ponds are there. Of course, now the Supreme Court has given the guideline that no ponds in the any of the region of city, no streams can be altered. You have to keep them as it is, and then you have to plan your areas. Encourage rainwater harvesting and rainwater harvesting structures. As far as possible, you can go for lesser runoff. So what will happen, it will have less impact on the stormwater drainage system. So I try to give you maximum possible in 1 hour, one and a half hour, for what we can say the rainwater design of rainwater system. And as I have got I'll say that response in the previous lecture. So I have not asked you question in between. You can ask me question now if you have any. So this is the entire design of stormwater smart cities. This is a very important one, and probably all the aspects, basic concepts that I have covered in this specific lecture. So if you have any specific question, either you can put in a chat, or I just look at check. No questions are there in chat. Just I will see any questions are there in chat. No, only attendance link is there. Okay. Any questions are there, you can ask me, or otherwise we can end this lecture here. You can ask me any silly question, no problem. Yes, anyone is there? I think someone has unmuted that. Yes, please. Dr. Vishal, you want to ask something? I think he got left. Okay. Anybody else? Any question?
Hello.
Yes, yes, please.
Thank you very much, sir, for delivering such a nice lecture. On behalf of organizing team, I thank you.
Okay.
Dear participants, if any questions are there, you can ask. Yes, Prashant Bhagwati is
So
asking,
this
sir.
Prashant Bhagwati, there are various software used in water supply, not stormwater, then water supply, na loop, LOOP, loop EPANET branch, loop EPANET. There is a loop software. There is another one, EPANET. This is for water supply. Branch. This is also for water supply. Branch. And if you have money, you can go for water CAD. Right? This can be used. Water, yeah, but you should have money. If you have money, because it is not a freely downloadable software, Prashant. It is costly software. Okay, anybody else? Any other question? No question. Okay. Okay then, Dr. Vishal, I thank you,
Thank
and I
thank you
thank
very
you.
much, sir.